Hi, welcome to another episode of PX and the Art of Programming. In this episode, I will go further into the concept of test code and we'll discuss some other issues, things that may come along. Right now you are looking at the main function of px at level 2. It's a simple C++ or C structure, main function, and the first thing that it does that it will fork itself off in case of a -b parameter. So you can launch px in the background. This is the loop where the actual running takes place, and what happens here is that the singleton px2g is declared. Here it is initiated. If this initialization fails, then this function will return immediately with a value of -1, meaning something has happened. And then this Boolean function will determine whether to run a test at startup, and if so, it will run the test code. If the test fails, then the value of -1 is returned. If it succeeds, then the actually running will start with the call of myg.run. And if the value b, it's a read-write parameter to the run function, and if the run function ends with no value in b, then the whole circus will stop. So px2g might ask the system to reboot itself, and then this loop will start again. But this line of code does the looping for a single run. So it's possible to reboot px by deleting the current singleton. A singleton is an object which only is only declared once, and this singleton will be deleted whenever this context ends. And then if you loop, then a new object will be created. Well, let's have a look how this all works. And I just typed in Command R, and now it runs. And it stops at the breakpoint and asks the singleton, myg, whether to run a test at startup. Let's look on the inside. This Boolean function simply returns its run test at startup variable. And now we'll do a reverse engineering stuff. It's a variable on the singleton. It's initialized with the value 0, and here it is initialized with the value of the content of the parameter file, and this is the parameter, run test at startup. And this macro defines it. Here it is defined. Definition px params run test at startup. And this is the text, run test at startup. Well, I have defined the value 1 in my parameter file. And just for completeness. Oh no, sorry, this is the real live file. I will change this. So for now it will skip it. And let's see if this really happens. Yeah, it skipped the test. Huh? And now we will go into a run and I will abort it. I have changed my parameter file. I will save it. And now the system will run the tests. And the parameter file resides in the px directory in the section my. And every file or directory with the term px.my is yours. You shouldn't move them away or so. It's your stuff. And my parameters is located here. And this is this file. The other one that I was looking at is the default version of the parameter file. More about that later. But by default, the run test at startup has a value of 1. Well, let's run it again. Now we get into this function. It will return the contents of its run test at startup. Let's look at it. This is the variable and it has the value of 1. I hope you can read it. I cannot enlarge this font. I'll step out. And here I'm going to step into the test function because it's now activated. The first thing that it does, the testing at level 2, is to ask the system to test itself at level 1. Now this test has passed OK, and then the double check, and this checks whether or not its px1 test passed OK has the value of 1. I might complete this code by asking for this. Okay. Let's see if this is true. Is the test at startup the check? Well, it should give the value of true. Then we'll continue. We get into the testing software. And here we can see that at first there was the value its px1 test passed OK has the value, the variable has the value 0, and after the test it should have the value 1. It's check, double check. Let's step through the tests and I will show you where, and here. Now this variable is given the value 1. And even here I could add this line of code. Just to be very, very sure that this test passed OK value is only added if all these statements have been executed. It is okay to write test code, but it is not okay to believe that the test code has run when it in fact didn't. It is all about code stability, code reliability, and it's all about better to be safe and sure. And to have complete guarantee at the most. Radio Gideo. And we'll step out of this. Now we're back at the testing at level 2. Then this statement should go OK. Px OK always, its px1 test passed OK equals 1. It should be fine, yes. Then here the threads are tested. There is a built-in system to launch threads. We will not go into that testing software, but we will go into this testing software. A string of numbers. It's in the section array. And an array is just like it sounds. It's a way to store a random access, in this case numbers. And this is the object definition. px.s meaning string and an n for numbers. And it's based on px.s. A px.s is a string. And this is a string of numbers. That's all. And the methods that are declared for a string are methods like a number add, to add a number to a array, to an array, to remove a number, to remove the first, to remove the last, to set an existing location, to count the number of numbers, sorry. And some functions that are no longer used. Oh, sorry. This particular string of numbers is a px2 string of numbers unique, with the U of unique. Every number has to be unique. And it is totally equal to a normal px2sn with the exception that you cannot add the same number twice. And this is tested. This test is the test of the array. It starts here. I pushed on the run button, and here are we to test the array, string of numbers. It's within the px test, string of numbers. Right. I'll remove this breakpoint. And now we're here. This is the testing of the unique string of numbers. This is the declaration of my testing object. Here, 5 numbers have been added, and then the adding of this number should fail. Let me step one step back. Run it again. There was something that I would like to explain to you. Yes, this is the simple call to add a number to a string of numbers which are unique. Now, to add a number without any other parameters, then this function will initialize the boolean, the generic boolean, the generic flag to the value 0, and it will ask the real number add function to add this number, and to tell the calling function with the value of this boolean if it went okay. And if I simply asked to add a number, then this should always succeed. Okay, pix okay always, b has a value. Are you with me? And now the implementation. Where are we? Number add, we're here, right. Step over it. Now we step into this function. Function is right under there, right below. The first thing that we ask ourselves is if the success boolean is a correct boolean pointer, meaning it has a value and it denotes to the value empty or 0. Well, it's okay. The value is, the address is filled, and it denotes to an unsigned char with a value of 0. Okay, so that's okay. Then the first thing that this function does is to ask itself whether or not this number already exists. And since it did not exist, b as the value of 0, then it will add the number and say that it was successfully added to the string of numbers. It's all about code safety. And then this one should fail because now I have already added the number 3123, and now we'll try to add the number again. Now what will happen? The success boolean is tested, but it denotes to a value of 0, so this is okay. Then it will ask itself whether or not the value 3123, here it is, already exists. And it already exists. And therefore, this function returns immediately without setting the value of success to 1. So the value of success is still 0. And in the testing software, px OK always not the Boolean value. It shouldn't be possible to add the same number twice if the string of numbers is unique. Well, this was the last test in the testing of the strings of numbers. Quite some testing lines of code. Even some tests that need to be filled in. When I have, when I feel inspired, I will fill these in. They probably work. They're not so complicated. And then the last thing that is done by the testing software is that it sets this string, it adds this string to the list of the tests that are passed OK. Let's step into it. The function is test passed OK set, and this is the string of the test, the name of the test. First, it will ask itself whether or not the test was already passed OK. If so, then we are ready. If not, then we set up a string with the name of the test followed by a new line character. We transfer it to a lower case, just to be sure. And we add this string to a string variable of the singleton px2g, which contains the names of all the tests that went OK. This is the setting that a test went OK. And right below this, right below this function is the function that checks whether or not a certain test went OK. And when I'm at it, this is quite old code, I will make some code adjustments. Just read with me what I'm doing now. This I find more readable. And even I think this is better. Just wait a second. I will explain this just in a second. px, okay, always, and then just demanding that the test is written in lowercase. It's better than to convert the test name to lowercase, because why should anyone name a test using uppercase characters? This can only be some kind of error. All the code, and I haven't mentioned that yet, but all the code in px is written in lowercase. No camelback structures like Apple uses. It's not needed. And this is debugging code also. This is what I call extremely safe coding. I will do it the same here. Just give me a second. Yeah. Just watch me type. I have learned a lot about coding from a book written by Steve McGuire, a former Microsoft programmer, and the book is called Writing Solid Code. Let me look it up for you. Steve McGuire, Writing Solid Code. Maybe it's the... Oh, Maguire. This is the one. This... get away. This is the book that I had in my possession. And I read it maybe in 1993. And this book made me decide to have the guts to write C++. And here you can't hardly read it, but here it says Microsoft's techniques for developing bug-free C programs. Steve McGuire, Writing Solid Code. And the main issue is to write with the utmost care. And that's what I have tried to do since then. So, for instance, if you this function test passed OK. This is the name of the test. Well, first of all, we check whether the name is in lowercase. And then we initialize two variables, b and a variable n. B is the simple Boolean value defined by this macro. They are both set to 0. And then the string that contains the names of all the tests that passed OK, then this string is asked whether there is a line that equals this text, S. And to give the number of the line, and to give the value 1 if there was a line equal to this string. And under debug, it is px OK always that B, telling whether or not there was a line, has a value of 1 or 0. Because B is an unsigned char. The begin px begin macro defines this variable and the B variable, and the type definition of this one is maybe it's this. Yeah. px1b is an unsigned char, so it's a positive number ranging from 0 to 255. So in all cases, B should have a value less than or equal to 1. No value 2 or 3 or whatever. And you can argue that all these debugging lines are redundant. They hardly have a meaning. But that is the essence of writing solid code. Because you never know what can happen in an unexpected situation. Yeah, you heard me correctly. You never can know what will happen during an unexpected situation. So there is never testing code enough. In this case, maybe is lower can be stricter formulated. No funny characters like parentheses and hashes and whatever. Maybe not. And to explain this macro, the px execution macro with an underscore, this means that the calling function does not have the standard return value of px status, but in this case the boolean. So if here the string is set up to check it whether or not it is a lowercase string. And if that operation to add this string to this string, if that operation fails, then a return value of 0 is returned. And then the calling software will think, ugly phrase, but then the calling software will think that the test has not passed OK, and will raise an assertion, an error. And that is just what we want. Well, back to this one. The last thing that this test software does is that it registers itself as having passed OK. Run it again. And we'll skip this one. It's the calling of px1 test. We believe that. Test passed OK sets px2 serial string of numbers. We end up here. Other tests are run. Oh, there's a px2 expressions test. A lot of testing. But now that we are here, the testing of expressions is huge. With all kind of sub-tests. And then again, all these tests are verified that they went OK. And only in that case, the overall test of expressions is registered as having passed OK. So, and then here we are at the top level of the px2 testing. Then we'll check whether these tests all went OK. Oh, I didn't mean that. One click too many. And this is the one that we were looking for. And it went OK. And then the last one, px2 expression, did it went OK? Yes. And did this one go OK? Yes. And then some other minor tests. And it should, well, just while I am at it, sorry, just there's always work to do if you want to write perfect code. And now I'm wondering where the accolade is coming from. Oh, let me check. Ah, this one here. Yep. This can go away. And this statement, test passed OK set, shouldn't be here, because it should be the last line. So these routines, these calls, they should be in a separate function. It checks the name of the month from the number of the month. The translation table checking. Oh, and furthermore about the reliability of code, as you can see, lots of dates are included in the source code. So from this I can read that this software was written in 2010 and this software has been written in 2019. It tells you something about the how old the software was and therefore how reliable, because new software is less reliable. It tells the story. It isn't done everywhere, but it is good practice. Well, is there anything that I have looked over before I will finish this up? I think I've discussed this enough. Let me do for a last thing. I will ask for the scheme at level 4. And that test is over here. It's a different... At level 4, the main loop is a bit more complicated because it works with threads. There's a reason for that, but I won't explain it now. Because there's a fork and a thread running within the forks. And when I'm at it, I will remove this code. It can go away. It's quite old. Right. Now here we can see that if the run test at startup is required, then it will run the test on level 4. Let's put a breakpoint here and run it. We'll do some compilation. Just be patient. It's about 80 files to go, 70 files to go, 60 files to go, 50 files to go, 45 to go, 30 files to go. Almost there. Yeah, 1 file to go. And we're running. Okay. Let's have a look in the log. Well, here we can see that the initialization up until level 4 went okay. So we should be here. Yeah, that's correct. Now start the level 4 test. The level 4 test will do a level 3 test. The level 3 test will run a level 2 test. You get the picture? Execute level 2 test. And then it will wonder whether or not the level 2 test went okay. Check, double check. I will step out of this test. This will take some time. At level 3 there are tests done with letting the operating system do certain stuff, like change directories and tarring and you name it. The test on level 3 has ended, and now it is checked, double checked that it did went okay. And then the level 4 tests are started. And the philosophy behind this is that it is silly to do level 4 testing when you do not know for sure that the level 3 tests went okay, did go okay. And the same holds for the level 3 testing. So at first you do the most low-level testing and then you will build it up. Just to be sure everybody is happy with working software. It's all about writing solid code. So to give a short resume, I have told you about testing. I've told you how to enable the testing at startup. Apart from the testing at startup, there is a separate test base which does a huge test, which will take about 20 minutes to half an hour. But this is never done at startup. This is done manually. But more about that in another episode of PX and the Art of Programming. Now I will just continue. And what will it do? Will it come up with something? If it does, I have a nice ending to this episode. So, you never know, nooit niet. You never know, never. Where are we? Running what? Oh, it's done. It's doing image processing. Well, okay, that will take some time. Yes, just wait for a second. On level 4, we have image processing software. Let me show you. Close everything up. Oh. Ah. There's something the matter. Programming for me to do. I've worked on this, so I'm sorry. I was thinking I would have a great ending to this, but the test software, the debugging software, found a exception, and this should be looked into. And I will do this. And you, my audience, my dear audience, thank you very much for listening to this. I hope I made some stuff clear, and hope that I will speak to you again in the next episode of PX and the Art of Programming, when I have fixed this little annoying little thing. And on German, I say to you, tschüss, and bye, my dearly beloved.